Okay, A.REI.3, this is reasoning with equations and inequalities, solving inequalities using multiplication and division. Terms to know, we don't have any new terms for this lesson, so there is no need to rewrite these in your journal again. We have an inequality that says x divided by 4 is greater than 5. So some number or numbers, plural, that is divided by 4 should be greater than 5. So think in your head right now how many values that could be, or just pick out a couple that you think could work and check it. We're going to solve inequalities just like we did equations. It's just with a different symbol. So the quick way of doing it was taking the denominator 4 and multiplying it by 5. And what we're saying is x greater than 20? And ask that question to yourself all the time. Is the number that is going to work for x greater than 20? So the number in question goes in the middle of our number line. The number to the left is 19, and the number to the right is 21. So checking our work, take a number that is greater than 20. So what number is that going to be? Well, that's going to be 21. So let's take 21, divide it by 4, and make sure that that is greater than 5. So 21 divided by 4 is a mixed number. That's okay. We're not afraid of mixed numbers. Some students like to take numbers that are greater than 20 that are easier divisible by 4. Maybe a 28 you could check. But for right now, let's just use this mixed number. So 4 goes into 21 5 times with 1 left over. And is that greater than 5? And that would be a yes statement. Now, looking at the symbol, if I were to go to the 20 now to check it, looking at the symbol, I'm not going to take any more time with that. I think it's a time saver for you. If it doesn't have the equal sign under it, it's not included, so we know that 20 is not going to be greater than 20. So that will be the open circle when we graph this later on. The other one that you want to check is the one on the other side, which would be 19. So if 19 is divided by 4, is that greater than 5? So 19 divided by 4 goes 4 times. There's 3 left over. Is that greater than 5? 4 3/4. No, it is not. So that is a confirmation that the numbers to the right of 20, the numbers that are greater than 20, are the ones that are going to work for us. So open circle on 20, and the numbers that we're working were the numbers to the right, and shade in that arrow. Next problem is a little different. We have a negative attached to the coefficient, which is attached to the x. So we have a negative coefficient of -3. Let's divide both sides by -3. So what it's saying is x might be greater than -8. So let's see if all of the values greater than -8 work. So -8 is the number in question. -9 is smaller, and -7 is larger. So pick a value from our number line that is greater than -8, and let's see if it works. So how about -7? So plug it in the original inequality, -3 multiplied by -7, because that's what we said. The numbers must work that are greater than -8. Is that, I'm going to put a question mark, compared to, what do we have, 24. So we have +21, we have positive 24. In the inequality, it states that it's greater than. Is 21 greater than 24? That's a no. That's a no. And that is what happens when we are multiplying with a negative here. We had a no statement. Even though we brought down our symbol, that -7, even though it's greater than -8, didn't work when we plugged it in the original inequality. So let's check the other side of -8 and see if maybe -9 works. Is -9 multiplied by -3 greater than 24? Positive 27, positive 24. So this is a yes. So the -9 happens to be the one that works. And how would that go in place of x? -9, is that greater than -8? No, it is less than -8. So what happens here with these inequalities is if you have a negative coefficient, you have to turn the symbol around to make the statement true. So final answer would be, let's get rid of this one right here. X is turn the symbol less than -8, because those are the ones that worked. All of the ones to the right will not work. Let's graph that. Open circle, because of our symbol, it doesn't have an equal sign under it, and all of the numbers less than. Problem 2, we have a fraction, and what we can do is move this negative sign either to the top, to the bottom. You could leave it in the middle, but I think for our purposes, it'd be easier to move it to the bottom. So let's relocate that. We have x divided by -4. That doesn't change the value. Is less than or equal to -8. So quick multiplication. We have x maybe being, if we bring the symbol all the way down, maybe being less than or equal to positive 32. So the number in question is 32. 31 to the left, 33 to the right. Okay, so let's pick a number that is less than or equal to 32. I would say pick 31. So let's go back here. X is 31 divided by -4. Is that, question mark, is that in fact less than or equal to -8? Let's see, that goes in 7 times, 3 left over. Okay, is -7 3/4 less than or equal to -8? No. We know that -7 is larger than -8. So we have the situation again where even though the symbol tells us that it should be less than or equal to 32, that multiplying by that negative turns the symbol once again, because the statement up here said that 31 is not going to work. So we have to turn the symbol. X is greater than or equal to 32. Let's pick out that 33 just to double or triple check. We think 33 should work. So 33 divided by -4 compared to negative 8. All right, so this is negative 8 and 1/4 compared to, okay. So is 33 going to work? Is negative 8 and 1/4 greater than or less than? So is it less than negative 8? Well, yes, negative 8 and 1/4 is getting closer to negative 9, which would be less than or equal to negative 8. So we know that 33 does work. It does make this true. So let's graph that final answer. Closed circle because of the equal sign, and then the numbers that were greater than 32, because 33 did work in our original inequality when we plugged it in back to the original one right here, and it did check out because this is less than or equal to negative 8. So we had to flip that symbol in the answer. All right, divide both sides by 12 as always. So what they're saying is x less than or equal to negative 2. So negative 2, we have negative 3, and negative 1. So if I just brought down the symbol like I always do, less than or equal, let's run a check. Are we going to keep the symbol the way it is, or are we going to have to flip it in the answer? Let's check negative 3. Negative 3 is less than or equal to negative 2. So 12 times negative 3, is that less than or equal to negative 24? That's the question. Is it? If it is, it works. So we shade that way. If it isn't, it doesn't work. We flip the symbol. The other ones will work. Is that less than or equal to negative 24? And that is a yes. This is a yes. This is in fact less than or equal to, which was in our original problem. So there is no need to flip the symbol. You could check the negative 1 if you want to. Just trust me that it won't work. So we have our graphed answer, closed circle, numbers less than are to the left, and shaded in. So here's the general rule to remember. The x variable is what we're looking at if the sign with the x coefficient is negative. In the last step, we have to turn the symbol the other way. In this problem, we did not have to. I don't really care if the 24 on the right was negative. That's not the one that turns the symbol. It would have to be the coefficient like it was in the previous problem and the problem previous to that. Notice when we turned them, it was the left side with the x that we flipped it. In your journal, I'd like you to write a few sentences on what you learned from this video. I know that this turning the symbol could get a little confusing, so have some questions ready for me in class, and I can answer those for you, and I'm sure many of your classmates can also help you out.